Hello everyone, my name is Sushil and in this video I am explaining some tips that help me to improve my network. Actually I am not good in network in initial stage. I am not good right now also, but I just want to point out some important point that I learned during my preparation. Okay, so this is the first point motto of this video, and second motto of this video is that if you are practicing lots of network theory because you are thinking like that if you are not good in network then you are not able to solve the analog electrons question, ADC question, or some other subject question that is related to circuit. So this is not like that. Actually you have a basic understanding of the network and basic of network and network theorem, that is KVL, KCL and Norton and voltage divider or current divider. That is enough for solving the other subject question. But in that scenario you have to good in calculations, whether you are dealing with the microampere, nanoampere or milliampere kind of issues. Okay, if you are not able to do that kind of calculation then you are thinking like that I'm not good in network, that's why I'm failing here. But actually not like that what I feel during my preparation. Okay, I am still improving myself, but I'm just trying to accumulate all the things that I learned till now. Okay, so in this video I'm covering one or two concepts that you have to think about. That if you know it is good, if you not know then keep in this your daily preparation. This will definitely boost your solving capabilities or thinking approach, how to approach any network question. Okay, so start with the first question. Acha, actually in this video I'm just taking a normal questions that is coming in gate with 1 marks. Acha, one more point I want to explain. First, second. First is about the number of questions. So what I studies, two questions, 2 marks, and two questions, 1 marks. 1 marks are questions are very easy to moderate if you know the basics of network and basics of network theorem. Then you are easy to solve that kind of question. Okay, so let's go with the first question that I'm going to explain here. This one I'm making one copy because I have to explain 2 point of this. Okay, so just a duplicate. In comment section I just want to know it is good or not, nothing more than that. Okay, so in this first question I want to introduce first point, that is about unit. In network theory unit is too much important during the solving. So whenever a resistor in kilo, resistance in kilo ohm, then always try to make current in milli ampere, because if you are applying KVL na, then you are always seeing the voltage drop according to the according sources or resistors. So when you are multiplying these both two na, it directly come to the volt, because milli and kilo are cancelled out. So if you're not doing that na, there is lot of possibilities that you are going to the miss some kind of calculation. So it is good habit to deal with the cancelable unit. So what I'm doing here, I'm just making it 1 milliampere, and this current I'm also assuming I in milliampere. Okay, so all option also get modified, but let's understand this point how much this is important, because it is given in already in option is there. Then if option is not there, just understand this thing. If option is not there, then you are not sure about the your answer it is correct or not. So in unity based question it may create a huge impact, so keep this point first. Okay, then second thing I want to explain in this, which loop you have to go to solve this type of question. Currently here three loops are there no? First loop is this, second is this, third is this. Which loop is better to solve? What you think about outer loop? Is outer loop is good or not? If you are starting from minus to plus, current is going from here to here, means minus plus to minus, because resistor always dissipate the power or energy whatever you are thinking, and current is flowing from here to here, means plus to minus, and current always flow from minus to plus. Okay, so if we follow the outer loops now, then it is okay till this point. Here you don't know about the voltage drop across the current source. So whenever you are finding such element that you not know about the drops or something kind of things, then don't follow that loop, because this thing will create a more equations or more unknowns. Because here you not know, na, you have to assume some kind of voltage across the current source, then you have to proceed. And if you proceed with this will take lots of time to solve one more extra variable. You have to solve one more extra variable. So you have to understand this point. And if we talk about the again second loop, that is this one. I'm shifting to the next page because already written something on that page. Okay, if we follow this loop, then again thing will come, because we don't know the drop in this current source. So we have to take some variable, because any kind of source is there is some kind of voltage, or without assuming, then we can't proceed to solve that circuit. So this is also not a good option to go with this loop. And what else? This one thirdly, it is good, yes, but why this is good actually? Because this is a node, it is I coming from here, and 1 milliampere, it is also I in milliampere. I have already taken, no? So I in milliampere, so I milliampere, I 1 ampere is coming from here, and current KCL, according to KCL, 1 plus I will flow from here to. So you have to just apply the KVL. What? Minus 5 plus 2 into I plus 2I plus 1. We are not noting the kilo or milli, because already all the things are taken care. We are dealing with kilo m and milliampere. That's why. So if you solve this, 4I plus 2, if you take this side, 3 4I, and I is equal to 0.75. This is milliampere, because already taken milliampere. So this kind of things I want to explain in this particular video series. So this is the first question. I taken 2 points. Okay, let's go to the next question. This is a normal question. If you do not know about the concept, like to flow the current, you have a closed loop. If there is a forward loop, then there must be a return path for that. So there is only one path. So we can't say current will flow in this loop, so current will be 0. This is a normal thing. Actually, if you are not going with this, na, you can note this point actually. But if you are not sure about this, then just assume I is going from there. Just assume I1 is coming from here, I1 is coming from here. Then again I1 and I2 is same, na, means I will 0. You can think like that also, because whatever current will flow coming from this here, that current will go from there here also, na. That's why. Please think once what I said in this question. And some other question are also there. Video is making little bit larger. That's why I am not explaining much. But uh, let's see next question also. I want to explain one more question in this video. I will try it in this one. First, you have to think what kind of theorem we can apply here, and what is the better approach to solve this. Actually, we have to find the current in 20 ohm, 200 ohm resistor. Okay, it is good that we are able to make 0.2 kilo ohm. It is good option. Okay, or current is always in milliampere, na? So it is good because it is numerical based also, unity kind of, na. What is the good approach to solve this question? Because if you going with the nodal analysis, you have to assume this voltage, and one current is going there, you have to assume the here. Now you are going with the nodal, now you have to apply V1, assume V1, and you have to assume V2 here and solve that. There is two equation. But what is the good option to solve this question? Actually, एक second. I already taken the 2022 to 2026 all the questions that came in GATE EC. Okay, I'm just creating a duplicate of this and want to explain. Okay. Okay. Achha. What is the good point if you know about the source transformation? this thing we can transform into current source, and this thing we can able to transfer into voltage source. If we convert that thing, then this is minus to plus, means whatever conversion is there, minus to plus, current 1 volt, because resistance into current is come voltage, and resistor will become in series. So 1 kilo ohm and zero point 0.2 kilo ohm, and again here 1 ampere is coming from here, and here one resistor is there. If we convert into the voltage source to current source, then again current will flow like this. How much current? 2 upon 2, 1 milliampere. Okay, and 1 milliampere is from here, and I guess one more resistor is come from here. You have to make the parallel combination, and that resultant is 1 kilo ohm, and resultant current is, because you can add also, no, so 2 milliampere from this, and this is a simple circuit. You can solve it easily. 1.2 kilo ohm. So if you know about all the things about the basic of network and network theorem, then all the 1 marks question are easy to solve, and you are easy to able to get the that 2 marks. So I'm just stopping this video here, and I just want some input from you. What thing we have to cover, and it is good or not? Okay. Thanks for watching. Thank you, and best of luck. Do it best from your side, and what else needed, please